Hello, Flame community. This is Jeff Kyle with the Flame Learning Channel. New to the 2025.2 update is the brand new Morph tool, allowing us to leverage machine learning to make a harsh jump cut smooth and seamless. In this video, we'll be covering just what a morph is in this context, where you can find it inside of Flame, and how to use it on your next project. In editing, when we either remove a middle section of a clip or combine two similar takes, the result is a jump cut. Stylistically, this might be fine, but if we're finding that the cut point is a bit too harsh or distracting, we can choose to morph the two clips together. This can be done manually, although that can potentially be quite the painstaking process. Some other programs can use motion estimation or optical flow techniques to morph clips together, but now, the Flame 2025.2 update introduces its own morph tool. It works in a very similar way to the machine learning time warp, in the sense that it's analyzing the existing frames and generating new frames in between the existing frames. The big difference between these two tools deals with the number of interpolated frames, whereas generally the machine learning time warp deals with adding one or two frames in between existing frames. The machine learning morph often deals with a larger number of generated frames in succession. We can find the new morph tool in one of three places: as a node in batch, in the timeline as a timeline effects, or in the timeline as a video transition. Depending on where you access morph, the settings are mostly the same with a few minor variations. I'll start with the video transition morph, which is applied by selecting the cut point between two clips, bringing up the video transition menu, and selecting the Morph Video Transition. This type of morph has context-specific transition settings that appear when we select the transition, but if I double-click either the transition in the timeline or this morph button, we're sent into the transition editor, giving us a better look at the settings. Starting on the left, we have frame interpolation options, allowing us to switch between the default machine learning, with no modifiable options to adjust, and motion vectors, which gives us the same options we have with a motion vector time warp. Next to that are the range options, allowing us to control when the morph takes place. In this case, the range is not modifiable since it's being driven by the duration of the video transition. Under the morphing section, we have the mix setting, where we can adjust whether the result of the morphed frames match the outgoing input, represented by 100%, or the incoming input, represented by 0%. And finally, the freeze buttons allow us to hold either the first frame or the last frame of the morph for the duration of the morph transition. Inside of this transition editor, I can see the outgoing clip, the incoming clip, and the morph transition in the middle of the mix keyframes. And when I start to scrub the morph transition, we first see that the machine learning model is initialized, taking a few moments to run the model. However, when I scrub the frames, if you look very closely, you might notice that it looks awfully similar to a regular dissolve rather than a machine learning morph. While the machine learning model was initialized and all of our settings are set to machine learning morph, we didn't actually see the machine learning morph. Similar to a machine learning time warp, first we initialize the model, and then, once the model is loaded, we can process the machine learning. Since I haven't hit render on this clip, we aren't seeing the result of the machine learning morph just yet. To change the default behavior for this, we can find the morph settings in the Flame Preferences under the User tab, Tools and Timeline Effects, and this Morph section. This controls the default behavior for the morph, whether it initiates with machine learning or motion vectors, as well as allowing us to choose what happens with an unrendered morph, whether it switches to a dissolve when we scrub or play, only dissolves when we play it, only dissolves when we scrub it, or doesn't do any dissolve swapping and just shows the result. Now, let's take a look at the machine learning morph in action. In this first example that I've had up, we have a shot of a squirrel. In the original clip, the squirrel turns around, pauses for quite some time, and then starts to climb the tree. Let's say our task is to remove all of that time in the middle section. If I leave it as a jump cut, if we're extra observant as it loops, we can see the jump, mostly because even though the squirrel is mostly in the same position, it is slightly out of position. I can add a default duration video transition dissolve, and it's better, but again, if we look closely, we can see and feel the dissolve. Now let's look at the machine learning morph. I'll take the same shot, apply the Morph video transition, and then, with the Morph transition selected, I'll hit render. The machine learning model initializes, and once it's finished a few moments later, the real rendering begins. As is the case with both this machine learning morph and the machine learning time warp, Linux users will be able to take advantage of their GPU, whereas Mac users will only be able to use their CPU for these tasks. Since I'm recording this with a Mac, it does take more time than it would on a Linux machine, but after a bit of rendering, we see it's finished and we can take a look. If we frame through the transition, we can see that the squirrel is morphing from the outgoing clip to the incoming clip, creating that seamless transition. Let's take a look at another example to go over a different way of using a morph. In this example, I have two shots of this person. The first shot is of them sitting, looking, and blinking, and the second shot has them raise their hand up to their face. When I take a look at the jump cut scenario, we can clearly see that even though the camera hasn't moved, the head is in a bit of a different position and the jump cut is quite obvious. If I add a dissolve to this clip here and reveal the clip beneath it, we can see what this looks like with a standard dissolve, and I think it's even more distracting than the jump cut. Let's take a look at what it looks like with the machine learning morph. Instead of a video transition, this time I'll use a slightly different approach. I'll take this overlapping clip, make a cut point just in the area I'd like to apply the morph, and apply a Morph Timeline Effects. Result-wise, this is essentially the same as using a video transition, just a slightly different way of doing it, although one difference between the video transition morph we saw before and the Timeline Effects morph we're using now is this grayed out button here, Set Mix to Range. When we apply the timeline effects, the mix is set to the in and out points on the clip, but if those in and out points change at any point, we get the option to update the mix keyframes without having to do so manually. Whereas before the morph was on the transition, now with the Morph Timeline Effects, the outgoing clip is the clip that the Morph Timeline Effects is on, and the incoming clip is the clip that's underneath the clip with the Morph Timeline Effects. With all of this set up, I'll select the clip with the morph and hit render. I'll speed things up so we don't have to wait too long, and when that's all done, we can see the machine learning morph has helped move the head into position over the duration of the morph, and it is quite seamless and almost perfect, all done right in the timeline. Our final example brings us to batch. I have a shot of this person lying on their side, and just as they move their head up, they blink. Our task here is to remove the blink, and I think it's a great use case for the machine learning morph. Since I don't want the morph to change the speed of the head move, I did a simple stabilize of the head in action, and then I've set up a simple GMask tracer to mask out just the region I'd like to morph. I'll pull out the new morph node, and straight away we see it has 4 inputs: outgoing clip and its matte, and then incoming clip and its matte. In my example, I don't need to morph the matte, but it's worth noting that we do have the option of performing a separate machine learning calculation on the matte in addition to the fill. Just keep in mind, if you are running this on the matte as well, these are 2 separate calculations. The analysis of the front frames is not used to morph the matte frames because they are essentially 2 separate clips. Otherwise, the rest of these settings are mostly familiar, but for the first time today, the range section is available to modify, mostly because it's assumed that we wouldn't want to morph across the full duration of the clip. With that in mind, I'll scrub the clip a little bit to figure out our frame ranges, and I'm thinking 1020 is the frame just before the blink, and then it's over by 1034. I'll pull out a mux node and offset the clip by that range we just landed on to be used as our incoming clip, and hook that up to the morph node. To recap, I'll use the F1 keyboard shortcut to cycle between our outgoing and incoming clips to confirm that we have captured our blink moment in the outgoing clip, and then our incoming clip takes place just after the blink. As a result of this operation we're performing here, our batch will be 14 frames shorter, so I'll adjust that as well. And the last thing to note is that since 1020 is the first frame of our blink, if I leave the settings as is, we will start to see the beginning of the blink as the morph unfolds. This is a great use case to freeze the first frame since I don't want any hint of that blink. With that enabled, I'll hook the rest of this up and render it out. I'll speed this up just a bit, and there we have it. No more blink in a very simple setup, all thanks to the new machine learning morph. If you like these videos and you're finding them helpful, please subscribe to the Flame Learning channel and click the bell to stay notified about new content. Feel free to comment any questions or suggestions below. Until next time, thanks a bunch for watching.
Bye.